Describes the required configuration of the Avaya ASBCE for the support of remote workers. ASBCE brings unique and market-leading functionality with advanced services for remote workers, which allows the Avaya client secure access to the full Avaya feature set without the complications of a VPN. The advantages of using the Avaya ASBCE remote worker include encryption and user authentication, enforcement of session endpoint call policies, firewall network address translation, NAT transversal. When a remote worker outside the enterprise network calls a user inside the enterprise network, Avaya ASBCE decrypts the SRTP media if present. The ASBCE then performs any required network address translation, analyzes traffic for anomalous behavior, applies the relevant unified communications media policies, and then passes the RTP/SRTP stream to the intended recipient. Remote worker configuration includes the following steps. Configure topology hiding profiles. Create an interworking profile for the call server, which can be a session manager. Create a server configuration profile for the call server and assign it to the interworking profile. Configure a URI group if required and a routing profile to be used for routing to the call server. Add internal and external signaling interfaces and internal and external media interfaces. Define the domain policy rules, application, border, media, security, and signaling. Create endpoint policy groups and assign these rules to them. Create a subscriber and a server endpoint flow which will tie all the profiles, interfaces, and rules together. Create a PPM mapping profile to support Personal Profile Manager, PPM, and Presence. Create reverse proxies for the PPM and Presence, as well as to support a file server for uploading a configuration file like 46XX settings TXT. If instant messaging using XMPP protocol is required, add an XMPP relay service. To complete the remote worker setup, verify the connection and routing between the call server and the Avaya ASBCE. Additionally, configuring TLS encryption for a remote worker requires uploading CA and identity certificates and creating TLS server and client profiles. A reverse proxy is a web server that terminates connections with clients and makes new connections to the backend servers on their behalf. Reverse proxies are required by the servers, which are located on an internal enterprise network and are not directly accessible from the outside. A reverse proxy is also known as an inbound proxy. The difference between the traditional or outbound proxy and the reverse or inbound proxy is that while the outbound proxy receives requests from clients on an internal network and forwards them to the internet, the inbound reverse proxy receives requests from clients on the public network and forwards them inside towards the enterprise. Transport Layer Security, TLS, is a standard protocol that is used extensively to provide a secure channel by encrypting communications over IP networks. Avaya ASBCE uses TLS primarily to facilitate secure communications with remote users. Transport Layer Security, or TLS, is a cryptographic protocol designed to provide end-to-end communication security over networks. It's an IETF standard intended to prevent eavesdropping, tampering, and message forgery. At the core of TLS is the identity certificate, a form of a digital ID that a communicating side, referred to as either a server or a client, uses to identify itself. To prevent a possible certificate forgery, root certificates from Trusted Certificate Authorities, CA, are used to validate the authenticity of the certificate. The client should have the server's CA root certificate in its trust store. The trust store is used to verify the authenticity of the identity certificate provided by the server. During a TLS handshake, the two communicating sides, referred to as the server and the client, exchange messages to acknowledge each other, verify each other, establish the encryption algorithms they will use, and agree on session keys. Take a moment to familiarize yourself with an example, TLS handshake between the server and the client. To support TLS protocol, server identity certificates should be installed on the ASBCE, representing the identities of the ASBCE internal and external interfaces, or A1 and B1. Avaya SBCE supports PEM-encoded X.509 certificates. Certificates not in this format can be converted using an SSL converter, such as the publicly available OpenSSL tool. Server identity certificates should be signed by the trusted private and public certificate authorities. System manager is usually the private certificate authority for all Avaya Aura applications. Alternatively, ASBCE supports third-party certificate authorities. In order to generate a server identity certificate, a certificate signing request, or CSR, should be provided to the certificate authority. The Element Management System component of the ASBCE provides a basic built-in CSR generation tool, which ensures that the generated certificate will be compatible with the ASBCE. However, using this built-in tool to generate a CSR is not mandatory. Here are the configuration steps required to support the TLS encryption for the ASBCE remote worker. First step is to obtain and install Trusted Certificate Authority (CA) root certificates from all CAs trusted by the call server and the remote worker endpoints. Generate and download a certificate signing request (CSR) for both the internal A1 and external B1 ASBCE network interfaces. During the CSR generation, ASBCE also creates encryption keys, which are stored internally. Take these CSRs to the respective CAs to generate signed identity certificates. The A1 ASBCE network interface will use a certificate signed by the call server CA. We will refer to it as a private certificate. The B1 ASBCE network interface will use a certificate signed by the public CA, which is trusted by the remote worker endpoints. We will refer to it as public certificates. Then install both the server identity certificates and associate them with the respective encryption keys. After installing the certificates, create TLS profiles to define the TLS settings for connections between the ASBCE and the call server and the remote workers. This includes creating private and public TLS client profiles and private and public TLS server profiles. Each TLS profile should have the respective CA certificates and server identity certificates assigned. Modify the SIP trunking configuration. At the end, restart the SBCE for all the changes to take effect. A certificate is used to verify that a party is trusted by Avaya SBCE. Avaya SBCE accepts both CA root certificates and intermediary CA certificates. EMS Web Interface provides an easy way to install the trusted CA root certificates. One of the ASBCE remote worker configuration steps is installing private and public trusted CA certificates on the Avaya SBCE. Private CA certificate should be generated by the certificate authority trusted by the call server. Avaya System Manager can be used as a private certificate authority within the Avaya Aura environment. Alternatively, majority of third-party certificate authorities are supported. Public CA certificate should be generated by the public certificate authority trusted by the remote worker endpoints. ASBCE supports X.509 PEM-encoded certificates. Certificates not in this format should be converted using the SSL converter. In our example, we are using the Avaya System Manager as a private certificate authority, or CA, and a third-party public certificate authority. We already have the public CA certificates. We will be downloading a System Manager CA root certificate. Connect to the System Manager web interface, log in, and navigate to Services, Security, Certificates, Authority. Click on CA Structure and CRLs. Click the link to download the PEM file to the local PC. we will be saving all the ASBCE certificates into the separate folder. Install the public and private CA certificates to ensure that Avaya ASBCE can identify and communicate with all external entities. Permit enough time for setting up encryption. Strong encryption takes a long time to set up. Ensure that the time is properly synchronized between all entities. X.509 certificates are time sensitive. Ensure that all entities interacting with each other match UTC times as closely as possible. Ensure that the used certificates are valid. One of the most common causes of TLS failure is an expired or not valid certificate. To install the System Manager CA certificate, switch to the EMS web interface. From the EMS dashboard, select ASBCE from the device drop-down list. Click on TLS Management, then on Certificates. Next, click on Install in the upper right corner. Select CA Certificate for type. Type a descriptive name. For the private CA certificate, we will use SMGRCA. Select Allow Weak Certificate or Key to allow certificates with smaller key size, for example, 1024 to be accepted. Browse for the System Manager certificate file and click Upload. Ignore the warning that the certificate is not a valid CA certificate, but is a valid self-signed certificate, and click on Proceed. You can verify and make a note of the certificate expiration date before clicking on Install. A confirmation message is displayed. Click on Finish to complete the private CA certificate installation. Install the public CA certificate in a similar way. Click on Install in the upper right corner. Select CA certificate for type. Type a descriptive name. For the public CA certificate, we will use Public CA. Select Allow Weak Certificate or Key. Browse for the public certificate file and click Upload. Ignore the warning. Verify and make a note of the certificate expiration date before clicking on Install. A confirmation message is displayed. Click on Finish to complete the public CA certificate installation. This completes installing the CA certificates. Avaya ASBCE security projects utilize TLS primarily to facilitate secure communications with remote users. Install a public and intermediate CA certificate under Client Desktop. A wide range of the Public Certificate Authority's root certificates are already installed in the Windows or other devices' operating systems' Trusted Root Certificates repository. Here we demonstrate how to install a public CA root certificate and an intermediate CA certificate under Windows if not already present. Windows supports CRT-type certificate files. Start with the public CA root certificate. Double-click to install or right-click on the file and select Install Certificate. Click on Next. Select Place all certificates in the following store. Browse to the Trusted Root Certification Authority's repository and click on OK. Click on Next, then on Finish. Click on Yes at the prompt, then click on OK. Next, install the chain certificate in a similar way. Double-click to install or right-click on the file and select Install Certificate. Click on Next. Select Place all certificates in the following store. Browse to the Intermediate Certification Authority's repository and click on OK. Click on Next, then on Finish. This completes installing CA certificates on a client's PC. a certificate signing request must be generated on Avaya ASBCE, which will then be signed by the CA. The signed certificate is used to identify the Avaya ASBCE. One of the ASBCE remote worker configuration steps is generating a certificate signing request, or CSR, which includes necessary details for creating a correct identity certificate. The following information should be configured in the CSR. Requesting organization's name and location, common name or CN for the private and public network interfaces, which is usually defined by an assigned FQDN. Subject alternative name or SUN, which is usually defined by the same FQDN but starts with the letter DNS. Encryption algorithm. Key size in bits. The recommended key size is 2048 bits. Key usage and a key encryption phrase. To generate a certificate signing request, or CSR, for a private certificate, start on the EMS dashboard and select SBCE from the top device menu. Click on TLS Management, then on Certificates. Next, click on Generate CSR in the upper right corner. Provide the requesting organization location and name details. Common name is typically an FQDN assigned to the ASBCE network interface. In this example, pvtrw1.aura.com is assigned to the internal A1 network interface for remote worker. Leave the key encryption and usage parameters as they are. Typically, the recommended key size is 2048 bits. Subject alternative name is the same network interface FQDN as before, starting with letters DNS. Passphrase will be used to encrypt the key. We will use Avaya 123. Enter it twice. Provide the administrator name and email address. Scroll down to see the fields. Click on Generate CSR. Click on Download to save the CSR to the local PC. Close the pop-up window when done. To generate a CSR for the external B1 interface, click on Generate CSR in the top right corner again. Configure the fields as before, using the external B1 interface's FQDN for common name and subject alternative name. In this example, it is pubrw1.aura.com. Use Avaya 123 for a passphrase. Click on Generate CSR. Click on Download to save the CSR to the local PC. Close the pop-up window when done. Scroll down to verify the installed certificate requests and the encryption keys. Note that you can delete them from the system if no longer required. Verify that you have successfully downloaded the two certificate signing requests. This completes generating the certificate signing requests. The Avaya ASBCE verifies that the remote server identity certificate was signed by the certificate authority and provides the configured certificate for mutual authentication. It is recommended to use the system manager or third-party certificates for optimum security. The next ASBCE remote worker configuration step is obtaining the server identity certificates signed by the respective certificate authorities and installing them on the Avaya ASBCE. An identity certificate for the ASBCE private side network interface, or A1, should be signed by the private CA, for example, the Avaya System Manager. The identity certificate for the public side network interface, or B1, should be signed by the public CA trusted by the remote worker endpoints. Certificate encryption keys should also be provided during the certificate installation. If the original certificate signing request, or CSR, has been generated using the Element Management System inbuilt CSR generation tool, the encryption key is automatically created and stored on the EMS server. First, we will use the previously generated certificate signing request and create an identity certificate for the ASBCE internal A1 network interface on the Avaya System Manager Certificate Authority. Connect to the System Manager web interface. Log in and navigate to Services, Security, Certificates, Authority. Click on Add End Entity. Type a descriptive username, for example, the same as the host name, which in our example is PVT-RW1. Enter the same passphrase as was used during the CSR generation, Avaya123, twice. For common name, enter the FQDN assigned to the internal A1 network interface for remote worker, pvtrw1.aura.com. Scroll down and click on Add. A confirmation message is displayed on top of the screen. Scroll down the middle menu and click on Public Web. Click on Create Certificate from CSR. Enter the username as before, PVT-RW1. Enter the passphrase as before, Avaya123. Click on Browse and locate the previously downloaded PVT-RW1 certificate signing request. The file extension is .rec. Scroll down and click on OK. Depending on the web browser settings, the generated certificate might download automatically. Alternatively, click on Download Certificate and save it on the local PC. Verify that you have now a PVT-RW1 certificate. The file extension is .pem. Note that we already have the identity certificate for the external B1 interface which we obtained from the Public Certificate Authority with an associated encryption key file, so there is no need to use the other CSR. To install both identity certificates, start on the EMS dashboard and select ASBCE from the top device menu. Click on TLS Management, then on Certificates. Next, click on Install in the upper right corner. Keep the default certificate for type. Provide a descriptive name, for example, PVT-RW1. Browse to the previously generated PVT-RW1 PEM certificate file. Keep Use Existing Key setting. Verify that the correct key file appears in the Key Type field, and click on Upload. Verify the certificate expiration date and click on Install. At the confirmation pop-up window, click on Finish. Proceed to installing the external B1 network interface remote worker certificate with the associated encryption key which we obtained from the Public Certificate Authority. Click on Install in the upper right corner. Keep the default certificate setting for type. Provide a descriptive name, for example, PUB-RW1. Browse and upload the previously generated PUB-RW1 PEM certificate file. Then browse and upload the Public Chain of Trust certificate. Select Upload Key File under the Key field. Browse to and upload the key file associated with the PUB-RW1 certificate. Enter the passphrase for the public key file. In our example, it's password. Finally, click on Upload. Click on Install. At the confirmation pop-up window, click on Finish. Verify that you have successfully installed the two identity certificates. In a high availability deployment, certificates are initially installed on the active SBCE and should automatically be synchronized to the standby SBCE. You can manually synchronize certificates between SBCEs by clicking on Synchronize to HA Pair in the upper right corner. It might take a few moments for the synchronization to complete. This completes installing the identity certificates. The Avaya ASBCE TLS configuration rests within the TLS profile. TLS profiles are of two distinct types: server and client. One of the ASBCE remote worker configuration steps is to configure the ASBCE client and server TLS profiles. A TLS profile defines parameters used when ASBCE is performing a TLS handshake with a remote entity. TLS profiles are the basis of the ASBCE TLS configuration. During an outgoing TLS connection from the ASBCE to a remote entity, which can be a call server or a remote worker, ASBCE acts as a client and uses the settings of the client profile. During an incoming TLS connection from a remote entity to the ASBCE acts as a server and uses the settings of the server profile. Parameters to configure in a TLS profile include an identity certificate, which will be presented when requested by the peer. Whether peer verification is required, this setting is typically set to required for the client profile and none for the server profile. Peer certificate authority, a CA certificate to be used to verify the remote entity identity certificate if one has been provided. Peer certificate revocation lists, which are used to verify whether or not a peer certificate is valid. Verification depth, which is used for the certificate trust chain verification. If just a single CA root certificate is used, then verification depth should be set to 1. In case of a chain of trust certificate, this setting depends on the length of the chain. Renegotiation parameters, including renegotiation time and renegotiating byte count. Handshake options, including accepted TLS versions and the advanced cipher settings. To configure a client TLS profile for the internal A1 network interface, start on the EMS dashboard and select SBCE from the top device menu. Click on TLS Management, then on Client Profiles. Next, click on Add. Type a descriptive profile name, for example, PVT RW1. Select the appropriate identity certificate from the drop-down list. For client profiles, peer verification is required by default. Select the System Manager CA certificate under Peer Certificate Authorities and type digit 1 for verification depth. Scroll down and click on Next. Select all TLS versions under Handshake Options. Keep the rest of the settings as is and click on Finish. Click on Add to create a client TLS profile for the external B1 network interface. Type a descriptive profile name, for example, PubRW. Select the appropriate identity certificate from the drop-down list. Select the public CA certificate under Peer Certificate Authorities. As there is another public CA in our public chain of trust certificate, type digit 2 for verification depth. Scroll down and click on Next. Select all TLS versions under Handshake Options. Keep the rest of the settings as is and click on Finish. Verify that there are 2 client profiles on the list. To create a server TLS profile for the internal A1 network interface, click on Server Profiles on the left-hand menu. Then click on Add. Type a descriptive profile name, for example, PVT RW1. Select the appropriate identity certificate from the drop-down list. For server profiles, peer verification is optional. Scroll down and click on Next. Select all TLS versions under Handshake Options. Keep the rest of the settings as is and click on Finish. To create a server TLS profile for the external B1, click on Add. Type a descriptive profile name, for example, PubRW1. Select the appropriate identity certificate from the drop-down list. Scroll down and click on Next. Select all TLS versions under Handshake Options. Keep the rest of the settings as is and click on Finish. Verify that there are 2 new server profiles on the list. This completes configuring the ASBCE TLS profiles. Server interworking profiles adapt to various communication servers and their requirements with wider interoperability as the goal. This feature allows to set certain parameters when Avaya ASBCE is part of the enterprise voice over IP network. A server interworking profile settings are divided into the following groups. General, for example, how to handle 3xx redirection responses. Timers, transaction expiration timer, or transexpire, for instance. Privacy. It could be used to rewrite the from header in a trusted SIP message with the p-asserted identity to maintain privacy for the from header. URI manipulation, header manipulation. Advanced. For example, the has remote SBC setting directs the Avaya SBCE to use the far-end firewall functionality. A server interworking profile is subsequently associated with the call server configuration profile. To create a server interworking profile for the call server, start on the EMS dashboard and select SBCE from the device drop-down list. Click on Configuration Profiles, then on Server Interworking. A call server interworking profile can be created from scratch or can be cloned from the Avaya RU pre-configured profile. Select the Avaya RU profile and click on Clone. Type a descriptive name for the call server profile in the Clone Name field. For example, Call Server IW. Click on Finish to complete. To edit the cloned profile, scroll down to the bottom of the screen and click on Edit. In the General tab, scroll down to select T.38. Then click on Finish to complete. This enables support for fax relay. Next, we will configure Transaction Expiration Timer to support the fast response timeout towards Session Manager. This is not a mandatory setting. Switch to the Timers tab and click on Edit. Change the trans expire time to 4 seconds. Setting the trans timer to 4 seconds tells the SBCE that if the call server does not respond within the set time, the SIP connection is not established. The default timer is 32 seconds and is defined by the SIP protocol RFC. Click on Finish to complete. Verify that the new profile is listed. This completes the server interworking profile configuration. You must have completed Remote Worker Interworking Profile module before starting this module. A server configuration profile determines the connection parameters between the Avaya SBCE and the communication servers. When configuring the ABCE Remote Worker, a server configuration profile for the Enterprise SIP server or call server is required. Server configuration profile contains the following settings: a SIP domain and a communication server connection parameters, IP address, port protocol. A fully qualified domain name can be used instead of the IP address if required. Optional digest authentication parameters. Optional heartbeat, which enables the Avaya ASBCE to periodically send a message to the SIP server to help monitoring the connectivity status of the server. When both the primary and the secondary servers are available in the network, this server status is useful to determine which server is active. Optional registration parameters, optional ping parameters, advanced parameters including grooming, interworking profile, FQDN. Grooming is always recommended, as when enabled, it allows reusing the same connection for the same port or subscriber. Interworking profile field is a reference to the interworking profile created earlier for this SIP server. Signaling Manipulation Script, or Sigma, allows customization of the SIP headers. To create a server configuration profile, start on the EMS dashboard and select SBCE from the device drop-down list. Click on Services, then SIP Servers. Click on Add to create a new call server profile. Give the profile a name, call server for example, then click on Next. Select Call Server under Server Type. In the SIP domain field, enter avaya.com. In the IP address/FQDN field, type the IP address of the call server, which, in our example, is the IP address of the Session Manager's security module. Set the port field to 5061 and the transport field to TLS. The different options available for transport are TCP, UDP, or TLS. If the TLS transport protocol is selected, a TLS client profile has to be assigned. Select a previously configured TLS client profile. Click on Next. Skip the authentication settings and click on Next. Select the Enable Heartbeat checkbox and set the frequency to 30 seconds. This enables the ASBCE to send the options request to the SIP server every 30 seconds. If ASBCE does not receive a response from that server, it will declare that server as unavailable. For the From URI field, enter an identifier for the ASBCE. The options request will be sent from this source URI. For the To URI, enter identifier for the call server. This is where the options request will be sent to. This feature is useful when debugging SIP trunking connectivity. Click on Next. Skip registration settings and click on Next. Skip the ping settings and click on Next. In the Advanced Configuration screen, verify that grooming is enabled. Grooming allows the system to reuse the same connections for the same port. Set the Interworking Profile field to Call Server IW. Click on Finish to complete. Verify that the new profile appears on the list. This completes configuring the server profile. You must have completed Remote Worker Server Configuration Profile module before starting this module. Routing profiles determine the criteria based on which packets are routed to their destination. The following settings in the routing profile provide the ASBCE routing system with the information about the next hop. Optional URI group. A URI group is a logical group of SIP users that is assigned to routing profiles. In a simple configuration, calls to all URIs in the same destination use the settings of the same routing profile. When multiple routing profiles for the same next hop exist, URI groups allow to set up alternative routing rules based on the destination URI. URI groups are also referenced by the endpoint server flows. Load balancing. If multiple next hop addresses are configured, the load balancing setting determines the selection algorithm. Available options are priority, round robin, weighted round robin, and the DNS or SRV, time of day rule for time of day routing, and one or multiple server configuration profiles for the SIP servers acting as a next hop. When configuring an ASBCE remote worker, a routing profile should be created for the call server for routing calls into the enterprise network. Routing to the remote workers will be based on the pre-configured default routing profile. During the subsequent configuration steps, these profiles will be associated with the subscriber and server endpoint flows. The pre-configured default routing profile should never be modified or deleted. To create a routing profile, start on the EMS dashboard and select ASBCE from the device drop-down list. Click on Configuration Profiles, then Routing. Click Add to add a new routing profile for the call server. Give this routing profile a name. Call Server TLS, for example. Click on Next. Keep the default priority load balancing algorithm. The next hop priority checkbox is selected by default. Click on Add to add a next hop address. Fill in the priority weight of 1. For the server configuration, select the call server from the drop-down list. The IP address of the call server along with the TLS transport protocol automatically displays in the next hop address field. Click on Finish to complete. Verify that the new profile appears on the list. Routing to remote workers will be based on the pre-configured default routing profile. This completes the configuration of the routing profile. Before going through this module, you must have completed Remote Worker Server Configuration and Routing Profiles module. To complete the system configuration, two device-specific features must be defined: the signaling interface for transporting signaling data and the media interface for transporting the media traffic. Signaling interfaces define IP addresses and ports, which the Avaya ASBCE uses for transporting signaling data. Avaya ASBCE has two network interfaces, which are usually assigned as follows. Network Interface A1 connects to the private enterprise network. Network Interface B1 connects to the outside public network. One of the remote worker prerequisites is to have an IP address associated with the A1 interface and another IP address associated with the B1 interface. When configuring the signaling interfaces, the A1 IP address should be selected for the internal or private signaling interface and linked with the preferred protocol and port, and the B1 IP address should be selected for the external or public signaling interface and linked with the preferred protocol and port. To create a signaling interface, start on the EMS dashboard screen and select ASBCE from the device drop-down list. Click on Network and Flows, then on Signaling Interface. Click on Add to create a new internal signaling interface which will be used to communicate with the call server. Start with a name like SIG-INT. In the IP address drop-down list, select Private A1 VLAN 0. This will automatically populate the IP address previously assigned to the A1 internal interface. Assign the port numbers for the protocol selected in the call server configuration profile. For TCP and UDP ports, the 5060 port is pre-configured. For TLS, enter 5061. Select the respective profile under TLS profile. If required, enable Shared Control and configure an unused TLS port. Shared Control is a feature of Avaya clients where a software client can be used together with a hard phone. Click Finish to complete. Click on Add to create an external signaling interface which will be used to communicate with the remote worker client. Type the name like SIG-EXT. In the IP address drop-down list, select Public B1 VLAN 0. This will automatically populate the IP address previously assigned to the B1 internal interface. Assign port numbers for the protocol selected in the trunk server configuration profile. For TCP and UDP ports, the 5060 port is pre-configured. For TLS, enter 5061. Select the respective profile under TLS profile. If required, enable Shared Control and configure an unused TLS port. Click Finish to complete. Verify that both new signaling interfaces appear on the list. This completes the signaling interfaces configuration. Media interfaces define IP addresses and ports which the Avaya ASBCE uses for transporting the media traffic, for example, voice and video. Similarly to the signaling interfaces, when configuring media interfaces, the A1 IP address should be selected for the internal or private media interface and linked with the preferred media port range. And the B1 IP address should be selected for the external or public signaling interface and linked with the preferred media port range. To create a media interface, start on the EMS dashboard screen and select ASBCE from the device drop-down list. Click on Network and Flows, then on Media Interface. Click on Add to create a new internal media interface which will be used to communicate with the call server. Start with a name like MED-INT. In the IP address drop-down list, select Network's private A1 VLAN 0. This will automatically populate the IP address previously assigned to the A1 internal interface. The 35,000 to 40,000 port range is already pre-configured. Click on Finish to complete. Click on Add to create an external media interface. Start with a name like MED-EXT. In the IP address drop-down list, select Networks Public B1 VLAN 0. This will automatically populate the IP address previously assigned to the B1 internal interface. The 35,000 to 40,000 port range is already pre-configured. Click on Finish to complete. Verify that both new media interfaces appear on the list. This completes the media interfaces configuration. Before starting this module, you must have completed Remote Worker Signaling and Media Interfaces module. UC policies have two high-level concepts: flows and domain policies. Domain policies control the call flows entering or leaving the enterprise network based on a wide range of conditions and parameters known collectively as rules, such as application rules and media rules, among others. There are 5 sets of rules in the Avaya ASBCE. Let us discuss application and media rules now. Application rule, which includes the settings for the maximum number of concurrent audio and video sessions. Media rule, which defines the RTP media packet parameters, such as prioritizing encryption techniques and media quality of services settings. Rules are assigned to the endpoint policy groups. Endpoint policy groups are used in the subscriber and server endpoint flows to enable Avaya ASBCE to determine which rules to apply to a specific request. To create an application rule for the remote worker, from the EMS dashboard screen, select ASBCE HA from the device drop-down list. Click on Domain Policies, then on Application Rules. Click on Default and then click on Clone. Type a descriptive name in the clone name field, for example, RWAR. Click on Finish. Application Rules default settings include the maximum number of 200 concurrent audio sessions with a maximum number of 5 sessions per endpoint. This rule can be changed if required, and a limit for video sessions can also be set. Click on Edit to make the changes. And click on Finish. Verify that the new application rule appears on the list. Next, to create a media rule, under Domain Policies, click on Media Rules. Media rules define the media packet parameters, such as encryption techniques and encryption priority for either real-time protocol, or RTP, or secure real-time protocol, or SRTP. Select Default Low MED. Then click on Clone to use the default low encryption configuration. Type a descriptive name such as RWMR, then click on Finish. Under the Encryption tab, notice that the preferred format is RTP as opposed to SRTP. If SRTP encrypted media is required, this setting can be modified for both audio and video. Click on Edit. Select Required SRTP Encryption Method in the Preferred Format number 1 field under Audio Encryption. Select RTP in the Preferred Format number 2. Verify that the interworking for audio is selected. Scroll down and enable Capability Negotiation, then click on Finish. Under the Codec Prioritization tab, the audio and video codec prioritization can be enabled. This feature is required for transcoding and transrating. Under the Advanced tab, additional parameters can be configured. For instance, BFCP, or Binary Floor Control Protocol, and FECC, or Far End Camera Control Protocol, is used by the Avaya Scopia video endpoint. These settings enable support for the BFCP and FECC messages traversing the ASBCE. In our example, no changes are required. For the Quality of Services settings, switch to the QoS tab. Differentiated services code points are used by default for prioritizing media packets with per-hot behavior set to EF or expedited forwarding. We will use the default settings. Before starting this module, you must have completed RW Domain Policies, Application and Media Rules module. Define border rule to control the NAT transversal setting by defining the NAT transversal feature following with security rule to define which enterprise VoIP and instant message security features are applied to a particular call flow, and signaling rules to define the action to be taken for each type of SIP-specific signaling request and response message. There are 5 sets of rules in the Avaya ASBCE application, and media rules are discussed earlier. Now let's look into border, security, and signaling rules. Border rule, which is used to control NAT transversal and the firewall settings. Security rule, which is used to configure the voice over IP security features, such as domain denial of service. Signaling rule, which determines which action to take for each type of SIP-specific signaling request and response message. The next set of rules are the security rules under domain policies. Security rules control the compliance, scrubber, domain denial of service, and MAC-based LDAP authentication settings. We will use the default low rule to create an RW security rule. Click on Default Low and click on Clone. Type a descriptive name such as RW-SEC-R, then click on Finish. Use the Scrubber tab to enable protocol scrubbing, which checks the incoming SIP signaling messages for various types of protocol-specific events and anomalies. We will not be using this feature. Use the domain DOS to configure the threshold for the number of SIP messages which are received by the ASBCE. The Authentication tab allows enabling MAC-based LDAP authentication. It is not necessary to complete this configuration for our example. The last rule we will look at is a signaling rule, also under domain policies. Signaling rules control handling specific SIP signaling requests and responses, either coming into or going out of the Avaya SBC. Select Default and click on Clone. Type a descriptive name, for example RW-SIG-R, then click on Finish. The General tab, as well as the Requests, the Responses, the Request Headers, and the Response Headers tabs, allows defining how ASBCE will treat the SIP signaling messages. Actions include Allow, Block, and Block with Response. Under the QoS tab, the signaling quality of service is enabled by default. Differentiated services code points are used for packet prioritization, with the per-hop behavior set to AF, or Assured Forwarding. Under the UCID tab, the Universal Call Identifier support can be enabled. UCID is used in the contact center environment in order to correlate calls between multiple applications. This completes the configuration of the domain policy rules. The rules should now be assigned to the remote worker endpoint policy groups. Under Domain Policies, click on Endpoint Policy Groups, select Default Low, and click on Clone. Type a descriptive name like RWPG, then click on Finish. Click on Edit and select the previously created rules for remote workers, the RW Application Rule, the RW Media Rule, the RW Security Rule, and the RW Signaling Rule. The Border Rule and the rest of the options are not required for the basic ASBCE configuration. Now click on Finish. Verify that new policy groups appear on the list. This completes the domain policy configuration for the ASBCE remote worker. Before starting this module, you must have completed Domain Policies, Border, Security, and Signaling Rules module. This feature provides complete and unparalleled flexibility to monitor, identify, and control very specific types of calls based upon the user-defined parameters. Endpoint flows are combined with subscriber flows to completely identify and characterize a call placed through the network. When a SIP request reaches the Avaya SBCE, its routing system compares the content of the request with the provisioned endpoint flows to determine a match for routing the request. The call processing consists of 2 stages, inbound, when SBCE analyzes the SIP request received from a SIP entity, which can be an enterprise call server or a remote worker, then tries to match the source IP address to an endpoint flow and determines the next hop address. The outbound, when the SBCE tries to match the SIP request with an endpoint flow associated with the next hop address to determine which endpoint policy group to invoke, as well as which signaling and media interfaces to use for connecting to the next hop location. The settings in that second endpoint flow are then used to route the request. Two types of the endpoint flows are used for remote worker routing: the endpoint server flow, which is used to route to the call server, and the endpoint subscriber flow, which is used to route to the remote workers. In the inbound phase, when a SIP registration request from a remote worker arrives to the Avaya SBCE, its routing system checks the SIP2 header URI of the request for comparison with the provisioned URI groups in the subscriber flows to decide a match. In a simple ASBCE configuration, the URI groups are set to a wildcard, which means any URI. Upon finding a match, the SBCE routing system validates whether the destination IP address of the request matches the provisioned IP address field of the signaling interface configuration. The destination IP address matches the IP address of the external or B1 signaling interface. Then the rest of the fields of the SIP request are matched to the provisioned values of the subscriber flow, for example, via host, contact hosts, and source subnet, which in a basic configuration are set to a wildcard. The check is now complete. The trunk server flow matches. The SIP routing system then uses the endpoint policy group field within the subscriber flow to determine the provisioned domain policy rules to apply to the incoming SIP request before proceeding with the route resolution phase. The route resolution phase involves checking the routing profile value to determine the next hop server and the transport. The routing profile here is a call server routing profile set for TLS communication over port 5061. On to the outbound phase. In the outbound phase, the provisioned server flows are checked to find a match for the next hop server. In this example, the call server configuration profile is associated with the call server flow. The SBCE routing engine then performs the validation checks, starting with comparing the SIP request destination URI to the URI group associated with the call server flow. In a simple configuration, the URI group contains a wildcard. Next, the destination IP address of the incoming SIP request is compared to the provisioned IP address of the received interface associated with the call server flow. The destination IP address matches the IP address of the external, or B1, received interface. The check is now complete. The call server flow matches. The SBCE routing system then applies the various domain policy rules associated with the call server flow to the outgoing connection, as well as the respective server interworking profile settings. The internal signaling and media interfaces are used to route the inbound call. Before starting this module, you must have completed Remote Worker Endpoint Flows Overview module. There are two methods to create a new endpoint and subscriber flow. The first method uses the Add Flow function of the Flows feature. You manually define a signaling or media flow by configuring all the necessary parameters. The second method is called cloning. You can copy an existing flow and only change those parameters which would make the endpoint or session flow distinct. After the remote worker has successfully registered with the call server through the SBCE, its routing system stores the information about the subscriber flow, which it has chosen for the registration, as per the process described on the previous slide, in the in-memory database. When a SIP invite reaches the Avaya SBCE, the routing system consults the internal SIP registration in-memory database to determine whether the SIP call originated from a registered remote worker. If the SIP registration database lookup is successful, the SIP routing system uses the subscriber flow previously matched during the SIP registration process for taking routing decisions, and performs policy invocation and route resolution using the provision settings of subscriber flow remembered. On to the outbound routing phase. In the outbound phase, the provision server flows are checked to find a match for the next hop server found in the routing profile of the subscriber flow. In this example, the call server configuration profile is associated with the call server flow. The ASBCE routing engine then performs the validation checks, starting with comparing the SIP request destination URI to the URI group associated with the call server flow. In a simple configuration, the URI group contains a wildcard. Next, the destination IP address of the incoming SIP request is compared to the provisioned IP address of the received interface associated with the call server flow. The destination IP address matches the IP address of the external, or B1, received interface. The check is now complete. The call server flow matches. The ASBCE routing system then applies the various domain policy rules associated with the call server flow, as well as the respective server interworking profile settings. The internal signaling and media interfaces are used to route the inbound call. If the original SIP registration database lookup fails, the SIP routing system refuses the invite by generating a SIP error response, unless the request has originated from a server. In that case, a server-to-subscriber process is followed. ASBCE Remote Worker requires two endpoint flows, a subscriber flow and a server flow. To create a subscriber flow, start on the EMS dashboard screen, select SBCE from the device drop-down list. Click on Network and Flows, then on Endpoint Flows. Under the Subscriber Flow tab, click on Add. Provide a descriptive name, for example, RW Flow. Most of the fields contain a wildcard, which allows to apply this subscriber flow to all source URIs, source subnets, etc., unless more selective configuration is required. Select SIG-EXT, Signaling External, under Signaling Interface. Click on Next. For Media Interface, select MED-EXT, Media External. For Endpoint Policy Group, select RWPG, Remote Worker Policy Group. For Routing Profile, select Call Server TLS, Call Server Routing Profile. Under Optional Settings, select the private TLS client profile and provide the presence server IP address if support of presence is required. In this example, it is the security module IP address of the Avaya Breeze server which hosts the presence services snap-in. Leave the rest of the parameters as they are. Click on Finish. To create a server flow for routing requests to and from the call server, for example, a session manager, switch to the Server Flows tab. Click on Add. Provide a descriptive name, for example, Call Server Flow. Select values as follows. For the server configuration, select Call Server. For a basic configuration, keep the wildcard for the URI group, transport, and remote subnet. For the received interface, select SIG-EXT, Signaling External. For the signaling interface, select SIG-INT, Signaling Internal. For the media interface, select MED-INT, Media Internal. For Endpoint Policy Group, select Call Server PG. For the routing profile, select Default. For Topology Hiding Profile, select Call Server TH. Leave the rest of the settings as default. Click on Finish. This completes Endpoint Flows configuration for the ASBCE Remote Worker. Before starting this module, you must have completed Configuring Remote Worker Endpoint Flows. Now let's look at how a call goes from the call server to a remote worker phone. Note that the subscriber flow and call server endpoint flow configuration has already been completed in the previous module. The inbound routing phase starts when a SIP request reaches the Avaya SBCE. The routing system first determines the identity of the originating SIP entity and compares the source IP address with the existing server configuration profile addresses. Then looks in all existing server flows to find the one that is associated with this server configuration. In this example, it is the call server flow. The SBCE routing engine then performs the validation checks, starting with comparing the SIP request source URI to the URI group associated with the call server flow. In a simple configuration, the URI group contains a wildcard. Next, the destination IP address of the incoming SIP request is compared to the IP address of the signaling interface associated with the call server flow. The destination IP address matches the IP address of the internal, or A1, signaling interface. The check is now complete. The call server flow matches. The endpoint policy group is analyzed to determine which domain policy rules to apply during the inbound routing phase. Here we have call server domain policy. To determine routing, the SBCE routing system looks for the subscriber identification parameter in the SIP request URI header. If found, the recipient is identified as a remote worker, and the routing system consults the internal SIP registration in-memory database for the IP address of the remote worker. It then uses this information to route the call. The subscriber identification parameter, sub-ID IPCS, is a unique number generated by Avaya SBCE for each remote worker during the SIP registration process. If the incoming SIP request does not contain subscriber identification parameter, the routing system proceeds with resolving the route through the server flows, for example, to a trunk server using SIP trunking, or if the SIP registration database lookup fails, the call is rejected with the SIP 403 forbidden error response. Before starting this module, you must have completed Remote Worker Subscriber Flow module. It is necessary for the ASBCE to intercept and modify PPM message content returned by Session Manager to a remote worker so that the remote worker communicates with the SBCE rather than directly to SM. Create Standard Personal Profile Manager, PPM, mapping profiles for the server types, Presence, Session Manager, Branch Session Manager. Personal Profile Manager, PPM, is used by the Session Manager to forward feature-related information obtained from application servers to the SIP endpoints. Examples of the PPM-supplied functionality include feature buttons and the presence indication. To support PPM, a PPM mapping profile is configured for the Session Manager and Presence so that ASBCE can intercept and modify the contents of the Session Manager PPM response to get the client to direct messages to ASBCE instead of Session Manager. To create a PPM mapping profile, start on the EMS dashboard screen. Select SBCE from the device drop-down list. Click on DMZ Services, then on PPM Mapping. Click on Add. Provide a descriptive name, PPM for example. Click on Next. In the server type, select Session Manager. Select Call Server from the SIP Server Profile drop-down list. For the signaling interface, select the SIG External. For the mapped transport, select TLS. Click on Finish. Click on Add on the right-hand side to link a presence mapping profile to the PPM mapping profile. In the server type, select Presence Server. Type in the server address. In this example, it is the SM100 address of the Breeze server running the Presence Services snap-in. Under Signaling Interface, select SIG External. Click on Finish. Verify that both Session Manager Mapping Profile and Presence Mapping Profile appear together. Before starting this module, you must have completed PPM Mapping Profile configuration. Here, we will configure the reverse proxy for extending the PPM messages to remote workers, following with XMPP profile to support XMPP-based instant messaging. Additionally, a reverse proxy is required for extending the PPM services to remote workers. It enables an HTTP or HTTPS connection between ASBCE's A1 private and B1 public interfaces and the Session Manager. If the customer uses older clients like Avaya 1X Communicator, the Avaya Presence Services provides instant messaging via XMPP. To support it, ASBCE requires an XMPP relay to be configured. Newer Avaya clients, for example the Avaya iX Workplace, formerly known as the Equinox client, supports instant messaging through HTTP's REST and do not require the XMPP relay. Requirements for the HTTP's REST instant messaging are covered in the 71400V Integrating Equinox Solution with Avaya Aura Collaboration Applications training course. Before creating a reverse proxy policy needs to be defined. Click on Configuration Profiles, then on Reverse Proxy Policy. Clone the default profile and provide a descriptive name, for example, WebSocket. Click on Finish. Click on Edit and set Allow WebSocket to Yes. Click on Finish. To create a reverse proxy for extending the PPM messages to remote workers, click on DMZ Services, then on a relay. Switch to the Reverse Proxy tab. Click on Add. Under the service name, provide a descriptive name, for example, PPM. Check the box for Enabled. Verify that a reference to the B1 external interface and the external IP address for remote worker is selected under Listen IP. Select HTTPS under Listen Protocol. Type 443 under Listen Port. Assign a public remote worker TLS profile under Listen TLS Profile. Select the A1 internal interface and the internal IP address for remote worker under Connect IP. Select HTTPS under Server Protocol. Assign a private remote worker TLS profile under Server TLS Profile. Select the previously created PPM profile under PPM Mapping Profile. Select the previously created WebSocket policy under Reverse Proxy Policy Profile. Finally, specify the call server IP address and port 443 under Server Addresses. In our example, it is the SM100 address of the Session Manager. Click on Finish. To support XMPP instant messaging for older Avaya clients if required, switch to the XMPP tab. Click on Add. Provide a descriptive name, for example, IM Relay. Verify that a reference to the B1 external interface and the external IP address for remote worker is selected under Listen IP. Type port 5222, which is specifically used for IM by Avaya 1X communicators under Listen port. Specify the present services domain under XMPP domain. In this example, it's avaya.com. Provide the present server IP address. In this example, it's the SM100 address of the Breeze server running the present services snap-in. Type 1X client-specific port 5222 under Remote Port. Select the A1 internal interface and the internal IP address for remote worker under Connect IP. Click on Finish. This completes configuring ASBCE to support PPM messages and present for remote workers. Before starting this module, you must have completed Configure Reverse Proxy and XMPP Profile module. Configuration file resides in the HTTP configuration file server used in the reference configuration. Whenever an Avaya IP endpoint is rebooted, it will attempt to download the xxxupgrade.txt, 46xxsettings.txt file, and trusted CA certificates from the designated file server. To support the automatic download of files from a file server by the remote worker hard endpoints, an additional IP address for the ASBCE B1 external network interface and a reverse proxy for this file server are required. In the Avaya Aura environment, a utility server can be used which is currently co-resident with the Avaya Aura Device Services application server. The same file server can provide the CA root certificate for the automatic download by the remote hardware endpoint. Here is the typical Avaya hard phone boot up sequence. Phone broadcasts a request for IP address. The DHCP server provides IP address for the phone, plus the HTTP's file server IP address in the site-specific option number 242. Phone requests an xxxupgrade.txt file, and when the file is obtained, reads the names of firmware upgrade files in the 46xx settings.txt file. Phone reads the active parameters in 46xx settings.txt file, then proceeds to obtain the CA certificate name, among other parameters. Phone downloads the CA certificate from the file server and installs it internally. In order for the Avaya physical endpoints to be able to access the upgrade file, the settings file and the CA certificates located on the file server, a separate B1 external interface and a reverse proxy is required on the ASBCE. First, we will add an IP address. Start on the EMS dashboard and select SBCE from the device drop-down list. Click on Network and Flows, then on Network Management. Switch to the Networks tab. Click on Edit on the right-hand side of the Public Network interface. Click on OK on the pop-up window, informing you that changes will take effect immediately. Click on Add a new external address. In our example, it is 10.10.1.13, and click on Finish. To create a reverse proxy for providing the HTTP access to the file server for remote workers, click on DMZ Services, then on Relay. Switch to the Reverse Proxy tab. Click on Add. Under Service Name, provide a descriptive name. For example, File Server. Spaces are not allowed. Check the box for Enabled. Verify that a reference to the B1 external interface and the newly added external IP address for accessing the file server is selected under Listen IP. Select HTTP under Listen Protocol. Type port 80 under Listen Port. Select the A1 internal interface and the internal IP address for remote worker selected under Connect IP. Select HTTP under Server Protocol. Finally, specify the file server IP address and port 80 under server addresses. In our example, we are using a utility services address. Click on Finish. This completes configuring ASBCE to allow the remote workers' hardware endpoints to download firmware upgrades, settings, and certificates from the file server. Before starting this module, you must have completed Remote Worker File Server module. Trace, or packet capture feature, enables you to trace an individual packet or a group of packets transversing through Avaya SBCE. Traces are saved into the .pcap files. You can view the file using Wireshark, a free and open-source packet analyzer application used for network troubleshooting, analysis, and software protocol development. Start Wireshark first, and then either open the file from within the Wireshark application or double-click the packet capture file to open. Trace or packet capture files are available for downloading from the EMS web interface. To configure and start the packet capture, start on the EMS dashboard and select SBCE from the top device menu. Click on Monitoring and Logging, then on Trace. Under the Packet Capture tab, you can select which interface you would like to collect the data from, or keep the default Any. You can select a specific local IP address, if there's more than one IP address assigned to a network interface, and a specific port, or keep the default Any. You can specify a remote IP address to trace, or trace everything by using a wildcard. You can choose to trace only TCP messages, or UDP messages, or both. Specify the maximum number of packets to capture. Tracing more than 9,999 packets is not recommended, as it can affect the ASBCE performance. Finally, type a descriptive name for the PCAP file and click on Start Capture. The packet capture starts. Monitor the status message while making a trunk call. Capturing 9,999 packets took a minute and a half. When the capture is complete, switch to the Captures tab. Click on Refresh. Here you can download or delete the trace files if it's no longer needed. The trace files are saved on the SBC component in the user's home directory. Click on the file name to download the trace file to the local PC. The file name includes the timestamp. You can view the file using Wireshark, a free and open-source packet analyzer. Double-click to open the trace with the Wireshark application installed on this PC. This completes tracing with packet capture. Trace SBC is a Perl script that parses ASBCE log files and displays SIP messages in a ladder diagram. As the logs contain decrypted messages, using Trace SBC provides an easy way to view the packet details even when the connection is using a TLS or HTTPS protocol. Trace SBC processes log files in real time so that you can view the packet exchange during live calls. Trace SBC is a command line interface tool. In a high availability deployment, it should be run from the primary SBCE. Trace SBC start options. When you run the Trace SBC command, it displays the choice of options. You can trace either only SIP messages or only HTTP or HTTPS messages, for example when tracing WebRTC calls, or only TLS handshake messages, and so on. Trace SBC packet details. Pressing the Enter key displays the packet content. Trace SBC filters. Filters temporarily hide some of the information. For example, the "-NO filter removes options messages and responses to them. Trace SBC useful shortcuts. While running the trace, using shortcuts will perform a certain action. Pressing the W key, for example, will open a dialog prompt to enter a file name to write the trace to the server log folder. The R shortcut turns on the RTP simulation and inserts a line representing an RTP media stream. Shortcut D switches the view to the list of calls. In a high availability SBCE, the trace should be run on the primary SBCE. To identify the IP address of the primary SBCE, start on the EMS dashboard and click on Device Management. The IP address of the primary SBCE in our lab is 192.168.20.13. To demonstrate the trace, we will first register a remote worker. Start PuTTY or any SSH terminal emulator. Connect to the primary SBC's IP address via SSH and port 222. Log in with IPCS. Type Trace SBC. Type S to start the trace. At the Start option prompt, keep the default SIP option and press Enter. The trace starts. Sign in as a remote worker. Scroll up to the initial register message and press Enter to view the details. Press Enter again to close the message detail pop-up window. Make a call to the office worker. In a real-life scenario, there can be dozens of calls happening at any moment. You can either use a filter, for example, -I, to filter an IP address, or you can use a D shortcut to display the list of calls. Use the arrow keys to step on a desired call if required, and press Enter. You can now view all messages related to the call. Use the arrow keys to navigate the trace. Stepping on a message and pressing Enter will open a pop-up window with packet details. For example, let's look inside the invite. We can see the source and destination IP addresses, source and destination port, and the transport protocol, as well as the source and destination URI. At the bottom of the invite, we can see the SDP details. Press Enter to exit the details window. Press D twice to return to tracing all calls. Press S to stop the trace. Press Q to quit the trace. This completes tracing with Trace SBC. The statistics screen provides a snapshot display of certain cumulative system-wide generic and SIP-specific operational information. SIP statistics provide a wide range of real-time data, including SIP summary, details about active calls and active RW registrations, CES summary, status of client enablement services logins, subscriber or server flow, active calls and active remote worker registrations to which the specific endpoint flow is being applied. Policy, active calls and active remote worker registrations to which the specific endpoint policy group is being applied. From or to URI, current URI group's call statistics. Transcoding summary, active transcoding sessions. Dynamic license summary, session license usage. To access the ASBCE SIP statistics report, start on the EMS dashboard. Click on Status on the top menu and select SIP Statistics. SIP Statistics Report displays information in real time. The SIP Summary tab provides data on active remote worker registrations based on the signaling transport protocol used, on active calls with and without SRTP media encryption, on active video calls, and more. The CES, or Client Enablement Services Summary tab, provides information about 1x mobile logins, if the CES feature is used. The Subscriber Flow tab displays information based on the selected subscriber flow. It shows active remote worker registrations based on the signaling transport protocol used, on active calls with and without SRTP media encryption, on active video calls, and more. The Server Flow tab displays information based on the selected server flow. It shows active remote worker registrations based on the signaling transport protocol used, active calls with and without SRTP media encryption, active video calls, and more. The Policy tab displays information based on the selected endpoint policy group. It shows active remote worker registrations based on the signaling transport protocol used, active calls with and without SRTP media encryption, active video calls, and more. The From URI and the To URI tabs display statistics for the URI groups if configured. The Transcoding Summary tab displays information on how many SIP trunking calls are using the transcoding feature, if transcoding is enabled. Finally, the Dynamic License Summary tab displays how many and which types of licenses are in use and which are reserved if dynamic licensing feature is enabled. This completes viewing the ASBCE SIP Statistics Report. Periodic statistics are statistics data collected per interval, like per system, per server or subscriber flow, per policy groups, per URI groups, etc. Periodic statistics provide a wide range of historical data, including SIP summary, details about active calls and active remote worker registrations for a chosen period, server flow, active calls within a chosen period where a specific endpoint flow has been applied, subscriber flow, active remote worker registrations where a specific endpoint flow has been applied within a given time window, policy group, active calls and active RW registrations for a chosen period to which the specific endpoint policy group was applied. From or to URI, URI groups call statistics for a chosen period. Before you can access the ASBCE Periodic Statistics Report, the Periodic Statistics feature needs to be enabled in the ASBCE. Start on the EMS dashboard and select SBCE from the top device menu. Click on Network and Flows, then on Advanced Options. Under the Periodic Statistics tab, enable the feature. Note, as Periodic Statistics collects historical data, there is a collection time period which can be set. Minimum collection period is 15 minutes, which is a default. This means that after enabling the feature, at least 15 minutes should pass in order for the report to display the data. Click on Save. A confirmation message is displayed. To access the Periodic Statistics Report, click on Status on the top menu and select Periodic Statistics. Periodic Statistics Report displays historical call data. First, select a time period to display and click on Search. The Summary tab provides data on the total number of remote worker registrations and subscriptions to the call server features, and on the total number of calls with and without SRTP media encryption, and according to the way how the calls were terminated. This report also provides statistics based on the different call characteristics, video calls, transcoded calls, and so on. The subscriber flow displays historical data based on a selected subscriber flow. Selecting a subscriber flow updates the information displayed. The data provided includes the total number of remote worker registrations and subscriptions to the call server features, and the total number of calls according to the way how the calls were terminated. This report also provides statistics based on the different call characteristics, video calls, transcoded calls, and so on. The Server Flow tab displays how many remote worker registrations and how many calls have been established based on a specific server flow. Selecting a server flow updates the information displayed. This report also provides statistics based on the different call characteristics, video calls, transcoded calls, and so on. The Policy tab displays how many remote worker registrations and how many calls were controlled by a specific endpoint policy group. Selecting an endpoint policy group updates the information displayed. This report also provides statistics based on the different call characteristics, video calls, transcoded calls, and so on. The To URI and the From URI tabs display how many remote worker registrations and how many calls were made to or from URIs listed in a specific URI group. This report also provides statistics based on the different call characteristics, video calls, transcoded calls, and so on. This completes viewing the ASBCE Periodic Statistics Report. View the list of users that are registered through Avaya ASBCE in the Registration State column on the User Registrations page. View the current status of the configured SIP servers. Use the Server Status option of the Status toolbar to view the status of the connection. The Server Status screen displays the list of servers based on the settings on the Server Configuration screen. User Registrations report provides details about registered and unregistered remote workers. Current registration state of the remote worker, type of a client or an endpoint used by the remote worker, which subscriber and server flow have been used for the remote worker's registration, which call server IP address the remote worker is registered to, including the port and the transport protocol on the call server side, remote worker's IP address, and which protocol is used on the remote worker's side. To view the remote worker registrations report, start on the EMS dashboard and click on Status on the top menu. Select User Registrations. View the information available in registered and unregistered users. If you maximize the report window and scroll to the right, you will find a Details link. Clicking on Details brings up information about which type of client or endpoint is used by the remote worker, which subscriber flow and server flow have been used for this remote worker's registration, which call server IP address this remote worker is registered to, including port and transport protocol information on the call server side. What is the remote worker's IP address, and which transport is used on the side of the remote worker? What is the current remote worker's registration state, and when was it last reported? This completes viewing the ASBCE User Registrations Report. Server Status Report is a single place to view information about all provisioned SIP servers, including call servers and trunk servers, server FQDN, server IP address, server port, server transport, heartbeat status. To view the SIP Server Status Report, start on the EMS dashboard and click on Status on the top menu. Select Server Status. View the information available for the call server. Here we can see the heartbeat status to the call server is OK. This completes viewing the ASBCE SIP Server Status Report.